Today's activity, we're going to be static stress testing a rebar chair. And today, I would like to walk you through some timeline modifications to show you how to improve your performance in these static stress tests. Easy for you to say. So, the first thing I want to do is locate the center of mass. From my Inspect menu, near the bottom I have center of mass. I want to check that and use this object, this rebar chair that I have designed. And you'll notice it gives me a little center of mass symbol right there. Now I can clearly see that these webbings that I designed are not aligning with the center of mass. They're a little bit too high. So that means I need to go back into the sketch that I used to create those webbings, and we want to edit that sketch. So if we zoom in just a little bit here, should be able to. Edit sketch. Take this and pull it down to approximately there. Finish the sketch. And let's check and see if we insert a new center of mass on this product. See if it aligns correctly. Now, most of the webbing is connected at the center of mass, so we can expect significantly higher quality results than if it was misaligned. All right. Now, another thing to check before you go into a simulation is your material. In this particular setup, my physical material that I chose was ABS plastic acetyl resin. Okay, so I'm going to drag and drop that onto the product, close out, and we should be able to go back to the design. Again, having the correct material and having a center of mass identified will help in this process. So we are going to simulation at this time. In a previous simulation, you would see there was a lot of failure, and we are not intending to have as much failure now that I've made a few of these modifications. So we can go in and start a new simulation. From the study pull down menu, we're going to click new simulation or type N on your keyboard. And we want a static stress test. Okay. We want to constrain the bottom. So let's use the view cube to move to this surface right here so that the bottom doesn't slip out from underneath us. press enter. And then for our loads, we want a structural load. And imagine, if you would, that some rebar is going to press straight down on the top right there. And instead of newtons, let's switch to 25-pound force. Okay, 25 pounds, meaning a certain length of rebar is weighted on that before it has another rebar chair next to it, 3 feet away, 5 feet away, to help share the load. Okay, so we're going to say okay to that. And then on our study, we are ready to simulate results. The results have not been computed. Would you like to compute now? Yes. So we're going to solve a fifth and final study, which will hopefully produce the best possible results. It will use cloud credits. Each of these are stored on the cloud so that you could compare different iterations and see which one is the best. It does take a little time to calculate depending on the complexity of your design. I believe this one calculates in less than about 90 seconds. So let me use this time to cover a few important points. You need to always have a constraint, meaning at least one surface that you intend to not have any motion at all, so that it is immobilized and remains stationary. In this case, I chose the surface that's touching the ground because I'm counting on the surface area of this rebar chair to not slip or sink in. You need to also ensure that you always have one load point. In some cases, there may be 2 or 3 required, but at least one load point. And by default, it's going to load in newtons. That's not always helpful. In some cases, you need to measure in pounds or tons. The rebar chairs that we've designed in class are very simple, cheap products, and they're intended to carry pounds of force, not tons of force. For additional rebar chair information, please click on the link in the description. I will provide links to some common rebar chairs and some common rebar chair vendors. So, again, to look at some of the previous results, you could click on Study 1, Study 2, Study 3, and see some of the previous results. Those are also visible on the web, or you can have them load into your Fusion environment. Your web test results are also available for you to have desktop notification sent out. And those viewables are retained as long as your account is current. If you're watching this channel, you probably have an educational account, which you just need to renew every year. All right, we're back in Fusion and our results are ready. Now, let's go through this process of animation, and we will examine the failure. You can see as it begins to put some force in, it has some deformation across the top. That green area that's shown is not catastrophic. So this is a significant improvement. the part is staying together. It is not failing. Again, check the links in the description for more information about rebar chairs. If you would like to design one, there are many possible ways to accomplish that, or you can purchase them from vendors.